What do you understand by inert pair effect, allotropy and catenation? Inert pair effect, it is a very simple and beautiful phenomenon. The tendency of p block elements, to preferably remain in their lower oxidation state increases on moving down the group. What? Let me repeat. In p block, elements have a tendency to become more stable in their lower oxidation state on moving down the group in p block. That means NS2, NP1 to 6. This is typically a p block configuration. In this, NS2 tends to become inert. This pair of electrons tends to become relatively more inert on moving down the group, and this phenomenon is called inert pair effect. And because of this inert pair effect, in 6th period, thallium plus 3 is not as stable as thallium plus 1. Lead plus 4 is not as stable as lead plus 2. These are the preferred oxidation states because 6s2 electrons in thallium and lead prefers not to react. It becomes inert, and that is why we call this inert pair effect. What is allotropy? If a substance, often an element, if an element can exist in more than one forms in such a way that chemical composition is the same, but physical and chemical properties become different, like diamond and graphite, then the substance is said to show allotropy. Please note, allotropes have different physical properties. They also have different chemical properties. There may be some similarities, but there are always notable differences. So if the same element can be present in more than one forms such that chemical composition is same but physical and chemical properties are different, then that substance is said to show allotropy. Examples being rhombic and monoclinic sulfur. A second example, a very famous example, is diamond and graphite. Catenation, C part. The tendency of direct bonding between atoms of same element. The tendency of direct bonding between atoms of same element to form long chains is said to be catenation. Master of catenation is carbon. Nobody beats carbon because carbon can just go on forming millions of carbon chains. Chains containing millions of carbon atoms one after the other, and that, my dears, is very unique property of carbon and carbon alone. Oxygens hate each other. Not more than 3 can combine, and even if 3 oxygen atoms combine, they give you something like ozone, which is very unstable and very, very reactive. So in general, atoms do not like forming bonds with each other, but when they do, they are a family, and the family has great strength, and that's why we find catenation as a very unique property of carbon. But those who want a written answer, these are the answer. Take a screenshot and just feel happy about this in case you need this.